Hello everyone, and today we have the Bernoulli's trials video number 3. This is the question and it looks super hard because it requires a XY graph. It feels like I'm doing calculus all over again. It says in a XY graph starting from 0, 0 or Q. Rolling a dice, even means go right by 1 time, and odd means go left by 1 time. And if I roll the dice 10 times, and following on, find for landing on Q. So if I roll this 10 times, it goes to the right, left. What's the probability of landing on Q? The only way for that to happen if I get 5 even and 5 odd, right? Because I go even, okay, even, odd, even, odd. It's the only way that for it to happen. So now there are ways that can happen. It can go even odd, odd. So just how many ways can I shuffle this up? There are 5 evens and 5 odd. That is equal to 10, choose 5. And now I don't know what this is, so let's solve it. 5, 4, 3, 2. There's 1, but I don't care. So this can cancel off, this can cancel off, this can cancel off. Now this is a 36 times 7, and that is 252. 252 times the probability of getting even 5 times, that is just 1 over 2 to the power of 5. And this stands for even. And 5 times of getting odd is just 1 over 2 to the power of 5. And this stands for odd. And formally, this would be a 10 choose 5 that's what your teacher wants for some reason. Yes, this is the answer. And that is equal to 252 over 1024. We can simplify this. Let's try it. 126 over 1012. And this also can simplify to 63 over 256. I think that's the max it could get. This one was equal to 63 over 256. Now, this was pretty easy. Now let's do inside the radius 3. We have the XY graph, and this was the point Q. I just erased some stuff that I shouldn't have for some reason. Even is equal to right 1 time, and odd was meant to go to left 1 time. And I roll the dice 10 times. And what's the probability of being it inside the radius 3? This is 1, 2, 3. This is -1, -2, and -3. When it is inside the radius 3, it shouldn't touch the 3. That's like calculus we've learned, right? It shouldn't touch the 3. It's kind of like as limit as n approaches to 3 from the left or the right. It doesn't exactly go there. Well, it does. That's why it's calculus. But just get the point that it doesn't touch 3 because it says inside the radius 3. How can that happen, right? I'll give you an example. It goes to the right or even 1 time, 2 time, 1 time, 2 times, 3 times, 4 times, 5 times, 6 times, and 6 times, right? If it goes to 6 times, then I go to the other direction 4 times. 1, 2, 3, 4. And that was the total of 10 times I went by 1. And I landed on 2. And that is inside the radius 3. So we have to divide and conquer. Okay? Yeah. It goes to the even. Well, this is just a little tricky, because I haven't solved it by myself yet. Okay. It goes to the right 4 times. Right, actually 6 times. That means it will go to the left 4 times. And that works. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. It landed on 2. And also, other way around works as well. It goes to the right 4 times and it goes to the left 6 times. And also, kind of, it is the behind question, which it is. It goes to the right 5 times and left the 5 times. So we can all land on inside the radius 3. Now, let's solve for this one. It goes to the right 6 times. It goes to the right 6 times. For it being an even, that is 1 over 2. That happens to be 6 times, and it lands on left 4 times. This means for right, and this means for left. And there are in separate ways that can happen. I shuffle them up. It can go right, right, left, left. You get the point. And that is equal to, for being it right, 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 and left, 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 left. How many ways can I mix those? That is equal to 10, choose 4, or 6, the same thing. This is equal to 10 times 9 times 8 times 7 over 4 times 3 times 2. This is 110. No, 210. 1 over 210. Or if your teacher wants it formally, you should write 10 choose 4 or 10 choose 6. So, what is all this? This is equal to, not 1 over 210, just 210. 210 over 1024. Because it's 1 over 2 to the power of 10. Okay, so we got this. And now, this. It's common sense on what everyone has. They're basically the same thing. Technically just alphabets, turned around. They're the same thing, so I should multiply it by 2. Yeah, and this one, it goes right 5 times and left 5 times. I can cheat my way and just put that there, but that's just too not right. So let's actually solve this just one more time. Why not? It goes to the right 5 times. Right 5 times, and going to the right, which is even occurring from a dice, that's 1 over 2 to the power of 5. This meant for going to the right, and 1 over 2 to the power of 5, this meant for going to the left. And times how many ways can we mix that up? If we have right, 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 and left, 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 left. How many ways can we mix that up? That is equal to 5, no, 10. Choose 5, my bad. That is 10 times 9 times 8 times 7 times 6 over 5, 4, 3, 2, 1. Let's cancel. And that is equal to 6 times 6, 36 times 7. And that was 252. 252 over 1024. 252. So, right here, we have 210 over 1024 times 2 plus 252 over 1024. And this is all inside radius 3. Right going 6 times and left 4. Right going 4 times, left going 6 times, and right going 5 times, left going 5 times. All of this is 420 plus 252, 672 over 1024. You can simplify that, you guys do it. So, I hope I helped you guys in the Bernoulli's trial. Thank you guys so much for watching my video. I'm glad I helped someone. even if it's in the slightest way, I am very pleasured to do so. If you guys want any more combinatorics / probabilities videos, then see you guys there. Bye.